Dave, could you talk about his experience? Not that, but yeah, talk about his experience running Lambda in production.
Yeah, so I'm going to talk about Apex. Has anyone heard of Apex or used it at all? Tried it? Okay, not very fast. This talk is, I'll say Finance is a compliance company. We mostly work with financial services, so we process about $2.5 trillion worth of assets a day and make sure that those companies are compliant with them. We're quite a big growing company and we're one of the market leaders. So a year ago, we weren't doing any serverless. I wasn't even working with Finance a year ago. And we had to focus on how to create a pipeline for serverless and how we were going to do it. We're on AWS, so we're using Lambda. Although we're talking about Apex, this also covers a lot of the problems we found with how to do security and deployment in general within AWS and Lambda, and how Apex is going to help to solve that problem. And also, when we started to think about how we're going to do this, we had to think about what our culture was going to be around serverless. We had a pretty good pipeline with our current applications, so we wanted to deploy fast, make sure that everything was as seamless with our current deployment methodology. We wanted to deploy easily, so not too much overhead, not too much tooling to learn, and consistently. So again, we wanted to have the same model that we have at the moment, which is CI/CD workflows with GitHub, with all the tools that we use within that, with our current EC2-based applications. So if we talk about how to deploy it within this, we wanted a tool that could add new code. We didn't want to do this ourselves as well. We didn't want to run this and make files. We didn't want to do everything in kind of a half-assed way. We wanted a tool that could do everything for us, package everything, handle versioning, and it had to work for our entire team. So we wanted something that could be good in a dev workflow. It's not just for dev, it's not just for ops, it's for everybody. We wanted something that could work for that. And playing nicely with continuous integration. So how does that work with builds and testing? And we found Apex, and Apex was kind of our choice. We looked at some of the other frameworks, and actually we decided not to pick a framework because we wanted something sort of a little bit less heavyweight. This is about July last year when we started looking at this, or a bit earlier than that. So Apex lets you build, manage, deploy AWS Lambda functions beasts. As most of the tooling does, it is a wrapper around the AWS API. There's a lot of really cool things that it can do for you when it comes to deploying. So it's command line driven. It's written in Go, single binary. It supports things like multi-environments, which is really great for us. We use multiple AWS accounts, and that's great for our support. And also does, again, the building and packaging for us. It's exactly what we wanted. Has some niceties, rollbacks if something goes wrong. This is what the command line output looks like when you're running Apex. So it does work for a developer, and it works on CI as well, so it's just a command line tool. And there's a lot of options there for running this in production. The structure is pretty standard for most of these frameworks now. You have a top-level project JSON file, functions directory, and then you have your functions. In this case, it's on hello, and then the code inside. Your project JSON pretty good in terms of how it works. This can actually be for every one of your Lambda functions within your project. So every one of your subdirectories will inherit this, which is a really, really nice thing. So you can apply memory and description to all of those. And project name, for example, will prefix all of your Lambda functions. So you can name Lambda functions the same in other projects, and it'll be fine for that because they're not unique. Function JSON, this is an interesting one because this actually overrides the project JSON. So in this case, we've changed the name, we've changed the memory. So at FunLabs, what we actually do is we configure every Lambda function individually. We don't have any shared configuration. We don't use the project JSON at all. We only use function JSON because we feel that it's better. We use roles, different roles for every single Lambda function. We have very specific needs for each one we do. So it does scale to a large amount of Lambda functions. You deploy from the root directory, and again, I think a lot of the other tools have kind of picked up this kind of structure, so it's pretty good to work with. So I thought the GIF was going to be somewhere else. When we want to deploy it, we just do Apex deploy, and we're shipping. So this is kind of the output. In this case, we're deploying to the US one, and when it'll run. So, as you can see, pretty simple how how it works. Output's quite nice, and the exit codes would be nice for CI, which is what we want. Once you finish deploying, you can go to the pub. So what was going on there? We created a zip file, which is really nice, and this actually pushes it directly to Lambda API as opposed to uploading to S3. Adds the configuration, so if you want things like deadlet arms or KMS arms, they're added, and finally the environment variables. Because of the way that Apex is actually structured within Lambda, you can do a lot of the things in the command line as well as in the function and project JSON files. So if you want to add environment variables to project JSON or function JSON, you can, or you can pass them on as flags. So it's quite configurable in that nature, and it all works in the same sort of pattern in terms of eventually ending up with everything in AWS Lambda. The config that we use specifically for Apex is a little bit more complicated than most people's because of the way we encrypt all of our secrets, and I'll come to that later. One of the things that the Apex doesn't do, it doesn't do CloudFormation. A lot of people are like, well, CloudFormation is how Gordon works, and Serverless, and what's the other one? No, all of them do, Spartan as well. They all do CloudFormation. So because it doesn't actually support anything, you have to do everything yourself, which is actually quite counter to the previous talk. You have to do all of the work yourself. So why is that? Well, in a DevOps world, you don't want everything done for you, right? So Apex does work with Terraform, and a fun fact, we use Terraform, another reason we chose Apex. To be honest, we don't really use Apex with Terraform in the kind of the nature that it was designed to be. What we do is we have Terraform in a separate directory, and we push it separately as using the Atlas tool that HashiCorp designed, which is the provider for Terraform. The main issue that we found when we started using these frameworks as well is that CloudFormation didn't support the things we want, so then we have to wait a while. I think Deadlet QArm, KNS arm, 2 months ago released. I think they're still not supported. Not very good. So we wanted the latest features, and CloudFormation isn't going to do that for us. So everything's created in Terraform. It's good for seeing the entire graph of your infrastructure, and it's just the way that we practice building infrastructure. Code is kind of separate to the way we deploy it. If you've never seen Terraform, by the way, this is what it looks like. The way we actually deploy and build Lambda is we create a Lambda function, and then we deploy to it using Apex. So everything is still created in Terraform, just the actual pushing. And you might ask the question, like, well, why don't we actually deploy using Terraform? Well, because we lose all the benefits or that Apex gives us of the packaging the code, doing the aliases for us, and deploying. We don't want to do like this. We don't want to have to build this complicated CI process again. We want something that did everything for us and worked with Terraform. So doing Terraform and then deploy to it using Apex is our approach. So Apex updates the zip file and environment variables. Doesn't store in S3, which is I think quite nice. Actually gives you the benefit of seeing how much data you've got in the Lambda API. If you go to the Lambda console, you can see how much storage you've got in there, which is quite nice. So why do we pick Terraform? Why don't we just want one tool, right? Because Serverless does everything for you. We want Terraform, we want Apex, we want them to work together. Well, we kind of see infrastructure as kind of an organism. It's always changing. Servers come up and down. And a great example is DynamoDB, for example. You have a lot of requests coming through an API gateway, and your DynamoDB throughput hits the roof. Doesn't stay the same as your infrastructure is declared because you've got dynamically changing up, changing down throughput. You need to have that available changes and dynamic changes on demand whenever. Same for example, if you're going to do changes to your Lambda execution time. What about if you're contacting an API, GitHub for example, and GitHub having a problem and it's taking a second to respond? You want to dynamically change the runtime to maybe 3-second timer, and that would allow you to actually keep functioning without having a problem. But you need to react to that, and it kind of has this whole mentality of infrastructure is always changing, so we don't want to change. Don't want to be static in that nature, and Terraform kind of gives us that capability as well. So we split the infrastructure from the deployment in a lot of ways. So infrastructure is in the same repository, but we do a lot of things ahead of time. So DynamoDB, databases, S3, etc. And we provision all this in time, ready for a Lambda function to come into operation. We can ensure, using Terraform, that we can predict the changes that are going to occur. The only thing we have to worry about is the code changes, as opposed opposed to sort of a bigger framework that kind of does everything for us. We're not necessarily 100% sure what's going to happen. One of the biggest problems we found, and actually CloudFormation has resolved this in a lot of ways, is diffs, right? So if I am about to change something, is it going to impact anything else? This is one of like the biggest things in infrastructure, right? It's obvious, but if you use any of the other frameworks, you're going to find that it basically just blows through. There's no diffing, there's no difference between the infrastructure. There are plugins, I think, for the serverless framework that lets you see diffs of infrastructure, but CloudFormation has a feature called change sets. It's just completely ignored, and it's a really great tool to actually determine whether you're going to change the DynamoDB table that's referenced in an EC2 application, and you change it, and it's going to break everything. So you want to have the ability to know everything in a graph before you actually deploy it. So we use Terraform, and it's good. CloudFormation is good for change sets, but you want to essentially manage your infrastructure separately from your deployments and manage it from the rest of your framework. It's kind of how I see it. Again, it's maybe not the easiest workflow because you have to learn Terraform, or you have to learn how to do CloudFormation separately, or any other framework you want to use to manage your infrastructure on another provider. Terraform is multi-provider as well, so it works on AWS and Google. So together, these kind of work really well for us, actually. We deploy often, and it actually makes sense for a lot of newcomers who just want to write codes, and sort of we can help them with the infrastructure, and likewise people who've got infrastructure knowledge but never done Lambda before, works really well. So to go back to the consistently part, to talk about continuous integration and how we kind of work with that, this is kind of our pipeline for deploying. So GitHub is where we store all our code, and we use TeamCity and Apex. TeamCity is a continuous integration server. And there's some bits on here which are kind of just for our application stack, but the important thing here is this thing down here, console. So if we talk about security for a second, we're going to talk about how we can structure our Lambda functions. As I mentioned, every function JSON file has its own Lambda role. So it's great for teardown and setup. Just create a Lambda function, create a role, create its own policy. Again, it's more boilerplate, but it makes it really easy to see what exactly how that's for what. We only deploy through CI, no laptop deployments at all. It's not allowed. If we go to secrets and configuration, just come back to console. So what is console? It's a distributed key value store. There are many like it. It's essentially where we've got our secrets. It's encrypted, which is great. These are some providers that are alternatives. Obviously, KMS, etcd, Zookeeper, S3. I'm sure everybody in this room rotates your keys often, right? You know, you're all doing that every week. You don't have like random configuration checked into GitHub or anything, so you know this is a problem for us, and I didn't want to go through it with serverless. It's there's stuff always changing, right? So how do we do that? Well, what we want to do is we want to deploy a Lambda function. As I said, we deploy it a bit differently. So when we deploy it, we pass in configuration on the command line, and environment, and the last one is the IAM role we're going to use to deploy it, but primarily it's this bit here, like these configuration. We want to store this in one place, okay? By the way, the bit that's not on here is the bit where we actually retrieve the configuration from console, but essentially it's just a help command. So we don't want to check our variables into Git. Apex supports checking configuration in environment variables. It's great, and it works really well, especially if you're doing kind of non-sensitive things. We're in the finance industry. Most of the things we do is sensitive. So we don't want to check them in. And even encrypted things, like even if you encrypt a variable, like a database password, it still lives, if you check it in, it still lives in GitHub or wherever. And you don't really want to do that. And it's especially bad when you're checking non-secure configuration in. But Amazon made all the variables encrypted, right? They're all great. It's all KMS. Well, it's only at rest. So if you wanted to actually go into the console and look at all the passwords, your environment variables, like database passwords, you can. If you have quite a big team and they will have console access, then you can see all of the environment variables, like database passwords, and get access to millions of pounds worth of financial data. It's not very good. Now, Amazon does let you select the KMS arm, again, not a CloudFormation, so not a serverless framework, but it is available in the console. The only other option you have is actually to decrypt encrypt secrets and put them into your environment variables. But Apex doesn't handle encryption. It's still a manual process. This is a problem that we have, and we would like to kind of have Amazon do this in a better way. Obviously, you know, Apex could do it. I've sort of done little pull requests actually to Apex to kind of suggest how it could be done, but it's still not a great process. So if you're wondering, like, is there a framework way to take care of all of my encryption of my secrets using KMS, it's not going to work in Apex, unfortunately. The benefits of having a single point of truth is that we don't want to maintain loads of different states of where all of our configuration is. So I'm sure, like most of you probably aware, like if you have like an API token, say Logly or Signalogic or something, and you check it in, and that changes because you're changing secrets every week, then it's going to break, right? Your configuration is going to break, and you don't know where all your configuration is. So what some people do is they open up Google Drive and they create a spreadsheet, right? You know, it's like, you know, this is where you're going to put your API tokens, and you know that's where you put. And it's like, oh yeah, it's no good. So what we do actually is we encrypt our KMS functions here. Encrypt using KMS on environment variable. Actually, Amazon do actually provide the encrypt code as well in the console. There is a problem with this. There's no way for Lambda to decrypt ahead of time, so you do have to decrypt within the function. I'm going to show some code now. But basically, this is how Amazon say you decrypt the code. And if you want to maintain this and want to deal with this in every single one of your functions, you can, but that's what you have to do. So I did a couple of benchmarks to figure out how much adding this overhead was. So like Apex doesn't support it, KMS doesn't support it, Amazon kind of don't really figure out that maybe we don't want our secrets like in the console all the time. So I was like, well, let's figure out what the overhead is. It turns out it's not that much. Now, this graph is kind of a bit skewed because the first invocation isn't cached, but if we go down a bit, but basically, with margin of error, with caching and stuff, with Amazon, it's basically very simple. There's no difference with using KMS and function. It's pretty fast. Again, I did another one. We're a bit weird. We write all our Lambda functions, or most of our Lambda functions in Go. So anyway, but basically, again, without the caching, then it's very similar. So adding KMS to your setup to encrypt your secrets, it's not going to affect you that much. I think these were actually done without VPC lambdas, which I do actually add a little bit of overhead as well. So I didn't test it with VPC lambdas. So if we go back to this again, so I mentioned we use Go. So we want to build our Lambda functions, which is a bit different. So we have to compile, so we're going to use our CI server. I'm sorry I had to block this out, but we haven't released this service yet, and it's quite a big deal. So the way we do it is under the first blue square is the project name, and basically when we change a environment variable or any config or anything, we just have our Lambda service here and our normal API service there, and we just deploy it together. So it's just done in that manner. It works quite nicely. So yeah, we use Go, Node.js, and Python. Obviously, it's really good. But Apex also supports Golang and Rust, as opposed to the other frameworks. Why we use Go, we had a lot of service code already written in Go, and I did some benchmarks for Go when it first started, and it isn't that much overhead, so it works out pretty well. There's also plugins as well that Apex supports for Go, so it's pretty nice. Apex does add support for these languages, and I did a quick tally. I hope I haven't missed any off here. It doesn't support C#. Out of curiosity, how many people have a C# Lambda function in production? No. Okay. How many people would have preferred Ruby over C#? No? No?
Alex serves the new Ruby.
No? Okay, fair enough. Just out of curiosity, but I think generally they mostly do the same kind of languages, and Apex has got these ones over. I think the previous talk mentioned, you're going to pick the tool that's going to give you the most flexibility within the scope of your application. So yeah, Serverless and Gordon are pretty good as well. So Apex gives us the flexibility we need. You know, we don't check anything to GitHub, and that is one of the things that we wanted to have with Apex. You know, all command line driven, getting those variables in from console is quite a big deal. So deploying from EC2, this was another big thing for us actually. Most of the frameworks, I think Serverless framework used to ask you for your root AWS credentials when you first installed it, which was kind of like, wow. But we like to use IAM roles for everything, so including on our CI server. It scopes Apex to let it do exactly what we want it to do and not just everything. So we don't actually provide any credentials to Apex, we do things for IAM roles. And that's great for multi-AWS account So with Apex, what happens is it assumes a role from the CI server and using the IAM policy, and that allows it to deploy to our dev account and our prod account. That kind of gives us that great sort of sense of sandboxing out to environments. Also works well with Apex's dev and prod JSON files. Again, you can scope those out. So there's a one-to-one mapping there. Just to fill in the blanks here, we just have like Sentry and Cloud metrics and Sumo Logic. We have a Lambda that pushes all of our log messages out to Sumo Logic, which is quite nice. Apex is for you if you want total infra and lots of flexibility. I think the infra side of things, I mean, it's AWS specific, so not too much flexibility, but enough flexibility that you can choose to do things in a specific way for your company. We had very specific requirements for our deployments, which you can see, probably nothing like most of you in the room. And we do everything through Terraform, again, just that complete different sort of scope that CloudFormation offers. But yeah, it's a great tool. It works with many different things. If you're doing CloudFormation, doing Terraform, it's great. And yeah, that's about it. So thank you.
Any questions?
How do you secure the access to console?
How do we put config in?
Yes, well, so you someone's got access to the console to see where we pass, how to secure it.
As in within the company, you mean?
Within the company as well, so is it only accessible within the company?
It is, yeah.
Okay.
So we have everything locked to like VPN, and then secured beyond that with credentials. Yeah.
And you mentioned earlier that you don't want all your developers to have access to all the secrets. Do you have do developers then have different roles that is they can't access certain keys and things?
Not within console, but just within, you mean console as a service, right?
Yeah.
Yeah. No, it's more of who has access to. Yeah, we limit the access to console. We try and scope the access of developers and that sort of thing to specifically so that they can do things to a point. But yeah, there is always going to be that line of someone's going to have to do it for you if you don't have the right access. Yeah, there's a problem. But I think if you're, console is one way, but KMS is another great way. Like if you're on CI, for example, on our CI server, and you have access to KMS on CI, then you can just pull down the secret that way and you don't have to use console. And if you give developers access to KMS to encrypt, but maybe not decrypt, then that would be another way, for example. Yeah. Let's go ahead.
Yeah, you mentioned like how I can promote from production to test on maybe pre-production test, because you mentioned create.environment.json, function.environment.json.
Yeah, so within our workflow, when we get to CI, we have different build jobs for different AWS accounts, and then what happens on the command line, if I go all the way back, what we do is we provide a flag. So here, environment. An environment is just a variable that we pull in from the build server. So we say, deploy with this IAM environment for dev, prod, whatever, and then that scopes it to the account it's going to. And then that will use the correct JSON file because, yeah, actually it's not on here, but yeah, there is a flag to do it in Apex. Yeah, so Apex on the command line can select the correct environment file for you.
How do you manage the interface between your infrastructure configuration and your application configuration in two aspects? I guess there's one, making sure that you get your infrastructure set up before the application deploys, expecting the infrastructure to be there, and also getting the config lined up. You create the database and then you need to know to access that database.
Yeah, so all of our infrastructure codes, like Terraform, is done before we go near the code part. There's nothing stopping you doing it together. But CI is the stopper for that. So I should have mentioned we use a tool called Atlas, which is a mechanism that deploys Terraform for you. I guess it's akin to the CloudFormation console in AWS. We roll that out first before we do a Lambda deployment. But the configuration side of things is, yeah, it's a manual process that you have to do before you deploy, otherwise it's going to break. In terms of adding it to the script here, and also making sure it's available in console or KMS or where you put it. So there's a lot of pieces there. But yeah, in terms of the infrastructure, we make sure that Atlas is run before we deploy the Lambda functions.
Do you have a safety net for if you accidentally fat finger the name of something in your Terraform and in your compilation of the Lambda, then what would catch that?
So like, yeah, if we change the bucket name or something.
Yeah.
No.
It's difficult.
No, it is difficult. That's kind of, you know, it's obviously where, I mean, even the frameworks wouldn't necessarily save you from that. But yeah, it's about like, there is human intervention, but that's why pull requests exist, right? Yeah.
Just talking about the sort of developer experience, as a developer changes some code in the Lambda functions that you're running, what's my sort of workflow and how do I know that my sort of changes have gone through into production or through testing? What sort of
Yeah, you create pull requests, gets reviewed, tests, merge in, and then hit the button CI to deploy to dev, and then if it looks good, what the process.
Okay, so each pull request is getting its own deployment of a Lambda function, is that how it's done?
Yes.
Okay.
Yeah. So it'll get deployment in terms. It will get an alias. It won't go into production or be the current release, but it'll allow you to then play with it in the console, or play with it how you want. So yeah, we wouldn't promote directly to the current release until we were sure. And you can do that with Apex and aliasing the Lambda functions.
Yeah, last one.
Do you find anything that you're working, okay, let's do this with Lambda, and then whether it could be put with Lambda or Apex, that you just figure out you want to do software, whether, I don't know, security, reliability, anything?
Security is like the main one. Yeah, like the secrets thing is like, was when we were looking at it, we're like, this isn't a good story no matter what you do. Actually, when we started doing this, Apex used to bundle the environment variables up for you in the zip file and then use a node shim to get them into the code. So you have these like plain text variables in your Lambda package, which was terrible. So that's where we went the encryption route, and then again, like there was nothing that Apex could do that's help us do that. So again, it's that manual process, which is the downside. Maybe Serverless will come along with some magical way of solving that problem. I don't know, but like I said, it's a difficult workflow problem because if you put them into your JSON file, for example, in Serverless and the YAML file or whatever, you then have to decrypt them to like use them locally, which is a problem because that means you have to give every developer decrypt access, which is a problem as well because now you've kind of annihilated the security aspect of it. Unless you have a dev config, and how do you know that's going to work? So there's a lot of problems there. It is especially for like database passwords. It's terrible. We're lucky that we don't have too many that broach that, but we have APIs that are quite expensive to access, and we can't be giving away the passwords. So it's a shame. Yeah. Cool.
Cool. Thanks, guys. Something still? There's a beer in the corner. Finish the beers.